So this problem's a continuation from the last part with the same parametric equations and the same bindings of the region R by this curve, the x-axis, the lines x equals 0 and x equals 2. But this time we want to find the volume of the solid formed when the region R is rotated by 2 pi radians about the x-axis. In other words, we want to find the volume of revolution this time. So let's start this off. Normally, to find the volume of revolution, we have our coefficients of pi, we have our limits in this case given in terms of x, and we would go and say, right, we're integrating y squared with respect to x. And that's fine. Unfortunately, as we're given parametric equations, it's not as simple as that because our y is in terms of the parameter t rather than x. So we need to convert this. And we can say, right, fine, we've still got our pi, we've still got y squared, but we really have y squared times dx by dt multiplied by dt, or integrating with respect to t. And we've worked out our limits in the previous part by substituting in the 0 in place of this to find the lower limit, which was 0, and substituting 2 in place of this and making sure we satisfy the condition t is greater than or equal to 0, which we found was 1. So we have some expressions, and we previously found that if x is equal to t squared plus t, dx by dt is equal to 2t plus 1. So we can use those parts and we can substitute them in to say really we're integrating y squared, which is 1 over 1 plus t squared times 2t plus 1 dt, or combining that together then between 0 and 1 of 2t plus 1 over 1 plus t squared. And that's what we now need to integrate. And it's at this point you have to recognise this expression and you go and say, there's a 1 plus t all squared in the denominator. That should be telling you something, that this can actually be rewritten as something as partial fractions. So let's take this out and deal with it as a separate problem then. And we've got 2t plus 1 over 1 plus t all squared. So it's a repeated factor problem. So we can rewrite that as a over 1 plus t plus b over 1 plus t all squared. Multiplying through by this denominator, 2t plus 1 is equal to a times 1 plus t plus b. To get rid of the a term, we can substitute t is equal to minus 1. So when t is equal to minus 1, 2 times minus 1 minus 2 plus 1 minus 1, which is equal to b. And to find our value for a, we can equate coefficients of, easiest one to do is of t, such that 2 on the left is equal to a. So we have our values for a and b, and we can replace those in our expression, such that we have pi of the interval between 0 and 1 of 2 over 1 plus t minus 1 over 1 plus t all squared dt, which is what we then need to integrate. And actually, I don't like this second expression because we've got the squared in the denominator, so let's bring that up to the numerator. So really we have pi between 0 and 1 of 2 over 1 plus t minus 1 plus t to the minus 2. And then we can apply usual integration rules. So we have pi, 2 over 1 plus t becomes 2 the natural logarithm of 1 plus t, minus 1 plus t raise the power by 1 minus 1, divide by the new power, and times by the differential of 1 plus t, which is just 1, so we don't need to write that. And make sure we have our limits between 0 and 1. Tidying that up a little bit further, we have 2 ln 1 plus t minus, divided by the minus 1 becomes a plus, and really we have 1 over 1 plus t there between 0 and 1. Then we can substitute in our limits, the upper limit first. So we have pi, let's keep that on the outside, of 2 times the natural logarithm of 1 plus 1, which is 2, plus 1 over 1 plus 1, which is 2, minus in the middle, 2 times the natural logarithm of 1 plus 0, which is 1, plus 1 over 1, which is going to be 1. So you've got pi times 2 ln 2 plus a half. ln1 goes to 0 there. 1 over 1 is 1 minus 1, which is pi times, you can either write it as 2 ln 2 or you can write it as ln 2 squared, which is ln 4, a half minus 1 minus a half there. And that is where I would leave that in that form. And that's what we get for the volume of the solid formed when the region R is rotated by 2 pi radians about the x-axis for the curve given by the parametric equations x equals t times 1 plus t, y equals 1 over 1 plus t, for t is greater than or equal to 0, and the curve is also bound by the x-axis, x equals 0 and x equals 2.